In this video, I'd like to talk you through the setup for labQ. Now you'll notice in this particular lab, we're not giving you a full-blown procedure, but rather we're giving you a goal, that is to prepare a high-capacity buffer of a certain pH and then make a low-capacity buffer, and to test the effectiveness of these buffers in resisting a change in pH upon the addition of strong acid and strong base. So you've got this goal to test. We've given you concentrations of various reagents. We've given you limited volumes of material that you're using. And the idea is to put this all together in a procedure that you will write out yourself. But once you see what's involved, you'll see that actually there's not a lot of options in terms of coming up with the procedure. I'm going to show you one possible option. You certainly can come up with others as long as you address the desired goal. So over here we see, okay, first of all, we're going to prepare our buffer of a certain pH. The idea is that you'll either have an acidic buffer, that is a buffer that's made of acetic acid and acetate, and the desired pH is less than 7 at 25 degrees Celsius. Or you have a basic buffer, which will be made from the ammoniamine and the ammonia, and the desired pH will be a pH of greater than 7 at 25 degrees Celsius. So one of those buffer systems you will be assigned, or at least you'll be assigned a particular desired pH. You will, of course, then need to do a calculation of what volume of the conjugate acid and what volume of the conjugate base you'll need to combine. The calculation is shown, or an example calculation is shown under buffer preparation example in labQ, where we show you a similar example involving hydrofluoric acid and sodium fluoride and the desired pH of 3.22. So you want to take that same approach applied to your own buffer system. You'll see that we're starting off with 1 molar acetic acid or 1 molar ammoniamine or 1 molar acetate, 1 molar ammonia. And that actually makes the calculation easier. And essentially you'll come up with volume of the acid component and volume of the base component in your buffer. Once you've done that, you will of course combine them and come up with this 100 mils of high capacity buffer. You're told then to make a dilution to prepare a low capacity buffer. Now you are to prepare again 100 mils of the low capacity buffer, so if you think about it, it should tell you what volume you need to use of the high capacity buffer in order to make the appropriate dilution. So now you'll have 100 mils of low capacity buffer and slightly less than 100 mils of the high capacity buffer. The idea then is you are to test each of these buffers for the addition of strong acid and strong base to see to what degree they'll resist a change in pH. Now, of course, once you've made your buffer systems, you want to see, well, what is the pH of that buffer before you add strong acid or strong base. Now, you're also told that you're only given 50 mils of the strong acid, 0.1 molar hydrochloric acid, and 50 mils of 0.1 molar sodium hydroxide. So that's the total volume that you have to do all of your tests. So for instance, let's look at our low capacity buffer and see, okay, what do we need to do? Well, you have to do a test both for strong acid and strong base, and you're supposed to do it in duplicate. So it seems to me that you're going to want to take that 100 mils and split it into two, also realizing that there will always be volume loss and things. So, don't try to use the exact volume to the final amount. Give yourself some wiggle room. So you want to divide that 100 mils essentially into two, and one will be for the sodium hydroxide, one will be for the hydrochloric acid. But then after you've divided into two, well, you got to do it in duplicate, so it seems to me you'll have to divide it even more. So that'll dictate, what sort of volume you'll be testing for your low capacity buffer against strong acid and your low capacity buffer against strong base. In a similar fashion, back to the high capacity buffer, you got to split that into two in the same way. Now you don't have quite as much. You can split it into two, and then again you're going to need to split it into two again because you're going to be doing things in duplicate. Now, in terms of, well, how much strong acid should you be adding? Well, again, you only have 50 mils of strong acid. You need to use that 50 mils of strong acid both for the low capacity buffer and the high capacity buffer. So again, I think you're going to have to split that 50 mils into two. And again, realize that, let's say for the low capacity buffer, the half of the 50 mils now needs to be used in duplicate. So again, it should point out more or less what volume of HCl you have to work with in sort of a challenging, if you will, this low capacity buffer. I would aim, one, to, in a sense, control the variables. So if with one replicate you decide to use X mils of HCl, well, with the other replicate you should do the same thing. And to make the test comparable with the strong base, well, then use the same volume in the strong base addition. So it's, in a sense, making sure that you're controlling the variables so that you can make an appropriate comparison. And whatever volumes you decide to use of strong acid, strong base for the low capacity buffer, will then apply those same volumes of strong acid, strong base to the high capacity buffer. One of the things that might be helpful as you're thinking about the experiment is to prepare a data table, to think, okay, what data actually am I going to be collecting? For the data table, don't forget that when an experimenter looks at the data table, it should have all the details essentially to be able to complete the experiment. So it's important to have a proper title with concentrations within the table itself. Make sure that you have the appropriate units, and it's very clear what was done in the experiment. And then back, of course, to the procedure. Your procedure should be written such that someone that's trained in chemistry could essentially repeat the experiment. So any key details need to be included. Of course, you don't need to say, well, how do you shake a volumetric flask? A trained experimentalist would know how to do that. But the exact quantities that you use will be important to indicate. So I'm hoping that this short little video might have given you some sense in how you should go about preparing for your labQ. I actually hope that you have a lot of fun with this, because in a sense you're given more control in putting this all together, and I hope that actually it's a more memorable and positive experience.